focus on the logistic regression. And as a matter of fact, logistic regression is one of the most widely used technique virtually all disciplines, from social sciences to even engineering to agriculture to medicine and so on and so forth. So it has a wide, wide areas of application. So in this, we are going to we'll be moving between the slide and the starter window. But before we go to the starter window, discuss models for specific kinds of outcomes in Stata. Stata provides a bunch of techniques, models for different dependent variables. You know that dependent variables can come in different levels of measurement. So how do you know which model to use? So that question will be answered. Then two models for binary outcomes. This will narrow down from general to specific. We will now look at the binary outcomes in particular. Of course, it's also the basis. After binary, then you have outcomes with more than two levels. Then we will do estimation. I deliberately want to add probit to this discussion because I always have this argument and debate about logit, and even if I fail to treat it, now people will still ask the question, so why not just treat it? So I will look at logit and probit and probably answer the question, which one should I choose? So when we get there, everybody will be able to answer that question. Then we look at one good thing about the binary logistic regression is the fact that it actually predicts probabilities, unlike your linear regression, which predicts values. Rather, the binary logistic or probit predict probabilities. So we'll see how that is done. And finally, one of the beauties of binary logistic regression is the fact that you could interpret in terms of odds ratio. And so how do we interpret odds ratio? So those are things we will cover in this presentation. And as usual, occasionally I will allow for people to quickly interject and react. So models for specific kinds of outcomes in Stata. These outcomes are the dependent variable. They are the variables on the left-hand side of your model. Uh, they can, those variables, can, if they are measured, they are continuous. So, and we've discussed this one in the last 2 weeks. So, the appropriate model for continuous dependent outcome is linear regression. And that's why it's possible to assume that the error is normal. We can assume that for others. So here we assume that the error is normal, and so we use the normal linear regression model. These are examples of dependent outcome that are continuous: weight, height, cost, profit, etc. They are measured. They are quantitative. So they are when we have quantitative dependent outcome like that, we use the linear regression model. The second type of dependent outcome is the binary, where you have two possible outcomes, like outcome whether the citizen voted or not, or did not vote. So they are not measured, but they are categories. So there are two categories: vote, not vote, belong to a court, or not belonging to a court, loan default or not default. So we can think of other examples like that. When we have, this is the kind of dependent outcome we will discuss about today. When we have this, then two possible models are provided in Stata: the latent variable model, the nonlinear probability model comprising of the logit and the probit. The third category or types of dependent outcome variable that we can have is ordinal. They are still categories, but they are ranked, like Lakert scale, educational attainment. They are all ranked. Lakert scale could be maybe uh, 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 highly satisfactory, not satisfactory, and so on like that. Or educational attainment, maybe you have no education, primary education, secondary education, university education, or tertiary education. Even though they are categories, yet we can see that one level is higher than the other. Those are the ordinal scale. So when we have this kind, then we can use the latent variable model also in Stata, or we use the ordinal logit or ordinal probit. The fourth one is the nominal, where you have, instead of two categories, you now have three or more categories. But those categories are not ranked, they are unordered. Example, you have marital status, which could be divorced, never married, married, widow. Occupation, which could be professional, white collar, blue collar, craft, and many. There are more than 2 levels. So for instance, marital status in this case has 3 levels. Occupation in this case has 5 levels. So, but no level is higher than the other level. So when we have that, we can use multinomial logit model, mlogit. It's also in Stata, or we use the multinomial probit model. So it's always either you are choosing ordinal logit, or either you are doing logit or probit, or you are choosing ordinal logit or ordinal probit, or you are choosing between multinomial logit or multinomial probit. The other type of dependent outcome that you can have is a dependent outcome that is a count variable, in which case is discrete. It's only counting number of cases, number of accidents, number of aircraft landing, number of aircraft taking off, number of passengers arriving, number of insects, and so on. If it's about counting discrete, then you can use Poisson regression model, negative binomial regression model, truncated models, zero inflated count models. These are all meant for outcomes that are count. But these are examples.
Prof, please, can you help us with your volume?
Oh, you are not able to hear me?
Yes, sir.
Okay. What about now?
I think it's better.
Thank you. So, dependent outcome variable that are count, we can use this battery of models for them. And you have examples: number of patients, hospitalizations, daily homicides, international conflicts, number of strikes in a year. They are all dealing with counts. So the last one is fractional. So fractional happens when the dependent variable is naturally on a scale of 0 to 1. Maybe the values are bounded within a range. You have example pollution level, for instance. There are also some indices like Gini coefficients, patient oxygen saturation, things like that, where the readings, they are constrained within a range of values. So particularly values between 0 to 1, they are called the fractional dependent outcomes. So, but all of this, you can easily see them use them in Stata. So if you go to your Stata window, you come here to statistics. You have seen that we have discussed most of the issues in this part. We have also discussed linear models, but here we are now. But you see this part where you have linear models, those are for outcomes that are continuous. Binary Those are for outcomes that have two categories, two levels. So ordinal, those are the ones that are categories, but they are also ranked. So these are categorical outcomes, those with more than two levels of possible outcomes. And then we have the count, and finally the fractional. So in this region, you must know the kind of dependent variable that are suitable for the model that you want to choose. So, but in future, you might go beyond binary, but for today, we will be looking at the binary. So in the binary, you have a number of other things: logistic regression, reporting odds ratio. Maybe those are the two we will be able to talk about in our presentation today. So I don't know if there could be a question before I continue.
Yes, Prof.
Great.
Prof, I have a question.
Great. Continue.
Okay. Sorry, my question is this continuous and count or discrete.
Yes. Yes.
Before now, I used to take the two of them as one. I normally say continuous or discrete variables. So I don't know the major difference between the two of them.
Continuous, always remember that they are measured. And if they are measured, it means they can take decimal values. So they are like amount you spend, expenditure, for instance, like distance. So like speed. So anything that is measured, they are regarded as continuous. They are measured on a continuous scale.
Okay.
But count, no, you are merely counting. So it will be, it's discrete. It's not continuous. It will always be a whole number. So if you are counting vehicles, you can't have 2.5 vehicles. If you are counting insects, no. If you are counting number of beds in the hospital, so counts are discrete. They are whole numbers. So they are not measured. They are not used, no measuring instruments. Is it clear now?
Yes, Prof. Thank you.
Yes. Any other good? No, me not say good. Any question, whether good or bad? But that last one was a very good one. Everybody is happy, I think so. So,
Sir.
Yes.
What's the difference between binary and dummy?
No difference. They have the two of them. They have well, the slight difference is that for binary you are simply saying that it takes two. There are two categories: go, no go, defective, non-defective, and so on. But dummy is when you now you assign values to those levels, 0. So for one level, 1 for the other level. So again, you can create dummy even if you have more than 2 levels. If you have 3 or more levels, you can create dummy. So dummy is when you assign 0 to features that is absent, and you assign 1 to feature that is present. Is that clear?
Thank you, sir. But I would still like to ask another question with respect to dummy.
Okay.
When using dummy that have more than 2 categories,
Yeah.
they always talk about reference points. So how do we choose the benchmark, I mean the reference, if we have more than 2 categories?
The one you choose is usually the one you want to use as the reference point. So if, for instance, you are talking about customers taking loan, which they can either default or not default. So you might want to use no default as the reference one, so that you are now comparing default, the result of default to the one that you are taking to be reference. Is that clear?
But that is just
So,
2
sorry, Prof.
categories.
Yes, I almost said the same thing. That is just 2 categories. She's talking about more than 2 categories now.
Yeah, when you create you even when you, let's say you have 3 categories, but if you have 3 categories,
In
you
the
can't.
case of marital status, and then
Hello?
in the case of marital marital
Okay.
status,
Yes.
and
In
where
the
you
case
have
of,
more than 2 categories.
yes. So if
So,
you have, and you want to create a dummy, you
yes,
see, let's first of all get something right. It means you are not going to use the if the dependent outcome you are talking about is not going to be binary any longer.
okay. I thought as much.
So what you are now talking, which I'm trying to respond to, is when your independent variable, when you are introducing dummy it as an independent variable. So we have not done, I think that should have been done, or maybe we didn't include it in where your independent variable, you have to create a dummy variable. Is that clear? So
Yes, sir.
if you are creating dummy variable for marital status, for instance, the rule says because there are 3 levels there, you can only create 2 dummies, so that you will avoid what we call you avoid the problem of multicollinearity, and that's what we call the dummy trap. So for marital status, if you are creating dummy, you can choose your reference to be no or married. So the first dummy would then be the one that will represent married, or the second one could be the one that will represent, that will represent the third level.
Not married.
Not married. There are 3 categories that we recognize: divorced, never married, married or widow. So
Single, divorce, or married.
So
Single, divorce, and married.
Single, divorce, and married. Single is never married.
Yes,
So
sir.
never married could be your
Reference.
reference.
Can we also, is it also possible to choose another another category as the reference point rather than using the never married?
Sorry.
For example, is it possible for me to use maybe categories of those that are under divorce as my reference point instead of using the never married? Is it possible for me to use divorce as the reference, those people that fall within the category of divorce as my reference point instead of the never married?
Yes, you could use any of the levels as your reference. That's the point I'm making.
Okay, sir. Thank you, sir.
For instance, if I'm creating a dummy for divorce, then the variable will be D1. Then I will look at the first case. If that case is divorced, I will assign 1 to that person. If that person is never married or widow, I will assign 0, and so on like that. Then I create another one for never married. So if a person is divorced, I give that person 0. And if that person is never married or single, I give that person 1. So I can create 3 different dummies. But to avoid dummy trap, you have to remove one particular dummy. Otherwise, of course, automatically Stata will even delete one of them. But these are taking us away from our focus. The discussion we are having now is about when the dependent variable in this discussion today is when the dependent, not independent variable, when the dependent variable is binary. So if it is binary, then what model do you use? This is the model you should use. If the dependent variable is 3 or more, no. In other words, you have 3 or more on other category, then you use multinomial logit this thing. So don't confuse this thing. It's about, in discussion today, is about choice of model for different dependent outcome variables. But
Hello, Prof.
okay, good.
I think the conclusion on what you have said is that the dependent variable determines the model to be used.
Exactly. The level of measurement of the dependent variable determines the model you will use. That's the message I'm passing across.
Prof, thank you. I have a short question with relation to the continuous variable you mentioned the other time, sir.
Okay.
Yeah. By continuous, you emphasized the need for measuring such that one can have some fractional, elements to the actual measurement. But I want to know, how is that related to the interval level, ordinal level, and the ratio level we usually know by way of level of measurement?
If it's continuous, is both ratio and interval.
Okay.
It's both ratio and interval. So, but when there are 4 basic levels of measurement. The nominal, you can see nominal here. The second one is ordinal. You can see ordinal here. But binary is a special case of the nominal. It's also nominal, only that it's 2 categories. Is that okay?
Okay.
Yeah. So the other one is count. Can't also belong to either the interval, as long as, because it's quantitative. So any measurement that is quantitative, including fractional, they belong to interval and ratio scale.
The ratio. Okay. It's all right. Thank you, Prof.
You are welcome. So let's make progress now. So this where we are now is I've shown you on the starter window where you have the models for those specific outcomes: binary, ordinal, categorical, count, fractional. Maybe in future we will have the opportunity to discuss, but today our focus is on the binary outcome. So, and I've explained what binary outcome means. Let's go back to our slide. So for binary outcome, binary dependent variable, you have two coded values. 0 is assigned to outcome or level that is negative or absent or did not occur. 1 for positive outcome or that outcome that did occur. So the binary, the models allow a researcher to explore how each independent or explanatory variable affect the probability of the event occurring. So the most commonly used models are the binary, logit, and sometimes we simply call it logit or logistic model, or the binary probit. So these are the two most commonly used models for binary dependent variables. But what is the difference between the two? The first difference we are going to establish is the fact that the logit model assumes a logistic distribution of errors, whereas the probit model assumes a normal distributed errors. But as you will see later, both of them usually produce identical marginal effects. Even though we are not going to discuss marginal effects, but you will see that output in most cases they are identical. So let's now go to, before we go to the Stata environment, we are going to use a special data set, and the data set is taken from Emrose 1987 study of the labor force participation of women, and then the data were taken or drawn from 1976 panel study of income dynamics. The sample consists of 753 white married women between the ages of 30 and 60 years. So we will be using the dependent variable labor force participation, and then that dependent variable has one for a woman that is employed and 0 for a woman that is unemployed. You can easily get the data using this link. So we are going to use this link. So what I've done actually is to create all the commands I want to use today. I've put them in a do file. So if you insist, I will share the do file with you. I think I can even share it right away for those who want to follow
Thank you, sir.
us.
Grateful, sir.
Eh?
Thank you,
We
sir.
are waiting.
Kindly share it with
You
us,
are
sir.
waiting.
Yes, sir.
Thank you,
You
sir.
are waiting.
Yes, sir. We are with
Okay.
you, sir.
Since you are always with me, I will do it right away. Let me look. Just a minute. I think you are following me now.
Yes, sir. Yes, Prof. We are.
Good. Sorry. I will call it do file. Do file for lecture 12. So I'm going to attach it. Yeah. This is let me put it under, you will see it under Stata resources. So if you go to the classroom, the Google Classroom, and you go to classwork, look for Stata resources. Look for Stata resources. You will see it there. How many of you have seen it?
We have, Prof.
Yes, sir. Received, sir.
I have seen it, Prof.
Okay, so it means we can always do the same thing simultaneously. So excellent. So it will make our work a bit faster. So if you click on the first line and you run, just run, then what I've done is running everything at once. So, and I don't want to run everything at once. So let me stop this. So what I will do is to run one line. I want to run one line. So I want to I run one line at a time. So I block that line, and this is the data. The data is now loaded from the internet. Are you able to do what I'm doing now? Nobody is responding.
Yes, Prof. We have. We've done that.
Excellent.
We've run that. Yes.
So go to the next round and highlight it.
Okay.
And then execute the selection.
Okay.
So if you execute the selection, you will see the descriptive or the description of the data set. So you see the variable. There are 753 observations. There are 8 variables. The size is 10,542. So data from 1976 panel study of income dynamics by Mrose. And then variable name LFP, you can see it's for paid labor force. If the white married woman participate in paid labor force, then 1 is assigned. If not, 0 is assigned. And we can even see the first, let me say, list some of these variables just for purpose of so let's say in so this is not, but this first one is not in labor force. K is equals to K. What does K means? K5 is having kids below the age of 5. How many? No kids below the age of 5. Kids between 6 and 18. That first person has 3 of them. And the age of this woman is 39. So that's just for you to see the data. But of course, you can come here to see the full data. So you can see the first person has no, is not in labor force, which means 0. It's not in labor force. No kid below 5. 3 kids between 6 and 18. Age 39. WC is wife college. Maybe the wife, if the wife has a college degree, yes, 1. If no, 0. HC, if the husband has a college degree. So for this first one, wife no college degree, wife no college degree. Sorry, just let me.
Hello, Prof. Hello, sir.
His Prof is just give him some time, please.
Yes. Sorry, my pay father. Sorry,
Hello, Prof.
Yes, am I back?
Yes, Prof.
I'm hearing you already, Prof.
Prof.
Yes.
I'm back.
Hello, Prof.
Yes, any question?
Please, sir.
Hello, sir.
Yes, sir, please. I lost my connection when you were saying you wanted to post the do file. So that's why I had stopped and I'm lost.
It's been posted. If you go to our Google Classroom.
Okay, sir.
So you
thank
will
you, sir.
see it under Stata resources. So you can just download it there. And
Okay, thank you, Prof.
Open it to your Stata and start running. Run after me the way I'm running now. Somebody wanted to ask another question. So,
Prof,
thank you very much. So, we have described, but we can also summarize the data. So I can block this line again. You see some commands in Stata, you can just abbreviate them or you write them in full. By now you should get used to that. So if instead of writing summarize in full, once I write SU, Stata will understand. So this is the summary of the data. Easily you will know that LFP, which is labor force participation, there are 753 observations. The average is this. Actually, the minimum is 0 and 1. So it's just adding the ones together and dividing. Yeah. So then and so on. The age, the minimum age is 30. The maximum is 60. Of course, that is given in the background to the data. The survey covers those in that age bracket. So there are like the K5, the highest number, the family with the woman with the woman with the lowest, or rather, with the highest number of children below 5 years has 3. The one between the highest, the woman with the highest number of children between 6 years and 18 has 8. So that's the summary. You can see the mean, the standard deviation, and all of that. So let's go back to our model. But before we continue, it's always good that you know how the logistic model is specified. So this is the model specification. So you are actually looking for the probability of labor of a woman participating in labor force. So and this is the model. This is a cumulative function of beta naught plus this K5, that's the number of children below 5 years, and this is the corresponding coefficient. This is coefficient for the variable of number of children between 6 and 18. This is beta H, coefficient for age. This is whether the woman had a college degree or not. So this is the coefficient. Whether the husband has college degree or not, this is the coefficient, and so on and so forth. The last one is the income. So this is the model specification. So that when you estimate the model, you actually know that, unlike regression, the model you are building is a model that is predicting probability, as you can see here. It's not just predicting whether a woman will participate or not. It's actually predicting the probability that a woman will participate in labor force. Is that clear, everybody?
Yes, sir.
Great.
Sir, can I ask you a question, sir? With respect to
Why not?
K5 and K18, why do we have 2 categories of age range in a model?
Categories of
the age
which one?
we have kids that are less than 6 years and those between 6 years and 18. I actually do not really get the logic behind specifying kids below 5 and then those between 6 and
No, I
8.
think what they are trying to, labor force. This is about women participation in labor force, and usually, children, you will expect in most cases, if the woman is still nursing the children, she might decide to stay at home if the child is still below certain age. It's only here after 3 months, or maybe in some other places, after 3 months or so, the woman will go back. So I think the essence of the formulation is to be able to know the extent to which children, number of children below 5 years determine or affect a woman participating in labor force or not. Does it make sense to you?
Yes, sir. Okay, sir. Thank you, sir.
So if your child, let's say you already have children that are age 6 and above, do you want to still be babysitting?
No.
No, except maybe for religious or other purposes. So, some women might choose to. So this model explicitly helps to capture that possibility.
Okay, sir. Thank you, sir.
Great.
Sorry, Prof. What about the beta knot?
The beta knot is intercept. It's intercept and it's legitimate. It's okay.
Oh, okay, sir.
Yes.
Thank you, Prof.
Great. So you must always know how to specify your model. Yes.
Prof, it's like somebody is raising his hand.
Who is raising? Is it my hand that is being raised or his own?
No, I think probably
Adio Matthew Olufemi.
It's just a mistake. Let's continue, sir.
Okay.
Thank you.
Right.
Thank you. I knew it was my hand you were raising. Not
Okay. All right, sir. Prof, you can continue.
So let's go back. So the the model, we can now go and estimate the model. So which means we must, in estimating the model, you must be able to I hope you are able to see the let me see if I can increase the font.
Prof, you're supposed to zoom in, not zoom out.
I'm trying to zoom in now. Is it getting better?
Yes, Prof. Yes, it's getting better.
Good.
Okay.
I think it can be better than this.
It's clearer. It's clearer.
Okay now.
So now we can now run the model, but before I run it from the do file, it's always good for you to know how to do it also from the menu side. So once you just come here, you come to binary outcomes, and you go here, you click this, then you see the window. So this is the window. So every other thing you can leave as default, but you select what will be your dependent variable. And going by the background that I gave, that dependent variable must be a variable that is binary, a variable with two possible outcomes. So you can now come here and select all the independent variables. So you select all of them. This is that. This is the model. Even if you don't do any other thing, it's okay. You can just copy this, come here, and paste. So what is this here? What you see here is actually what is here in line 4. So I can run line 4 now, block it, and then run. So by now it has run. So we have an output. So you will see the output look fairly similar to what we used to see in the regression. The model is estimated using by computing the log likelihood function. And unlike OLS, where you are minimizing in the linear regression model, where you are using the OLS, which minimizes the sum of square of the errors, here you are actually maximizing the log likelihood, and the process is done through numerical iteration. So once the convergence is reached, it will stop. So it reaches convergence after the 4th iteration, and so it stops. So this is the log. This is what is happening here. So it started from -514 down, or is maximizing. So this is bigger than this. So is up from 514 to 452. So this is the maximum log likelihood. So you have other information about the number of observations. This is the log likelihood ratio, which is the test statistics chi-square with 7 degrees of freedom. We have 1, 2, 3, 4, 5, 6, 7 variables. So this is the computed LR log likelihood ratio, the likelihood ratio statistics. So
yes,
this
sir.
is
Prof,
okay.
yes, sir. Please, sir, how do we interpret the result of this log likelihood, sir? The value we're having there, sir.
The what?
The result of the log likelihood. So I said, how do we interpret it, sir?
I'm still there now. I'm still there. I've not left the place, so why not wait?
Sorry, Prof.
I said I'm still talking about the output. That's what I'm trying to do.
Yes, Prof. Sorry, sir. I want to ask, instead of typing in the command window, instead of typing logit, what if somebody just type regress LFPK5K? Would the result be the same?
How will it be the same? You use regress when your dependent variable is continuous. When you are doing the linear regression model. That's when you use regress.
Regress.
So if you
Okay.
use regress now, you can even try it yourself. The
Okay.
result cannot be the same. The result that is giving you is the result of regression,
Okay.
not
Okay.
the result of
Logit.
not the logic, not logic regression or logistic regression.
Okay.
Is
Thank
that
you,
clear?
sir. Yes, sir.
Yes. So, of course, this is the probability value for the the LR test statistics, and you can see is 0, very close to 0, and it simply says that these variables they jointly help to predict the probability of a woman. As I said, we are predicting probability, not just a woman participating in labor force, but rather predicting probability of the woman participating in labor force. So these are the fact that this one is significant shows that these variables jointly they uh, they 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 help to explain the probability of a woman participating in labor force. But individually, this is what this probability helps to do. So jointly, they can influence, but individually, some may not influence. Take, for instance, this one is not very significant. Women having children between 6 and 18 is not significantly, it's not very significant in affecting the probability of a woman participating in labor force. Other variable that is not that important is the husband college, but other ones seem to have serious, they significantly affect probability of woman participating in labor force. So, okay, yes.
Do we interpret as probability or the likelihood of participation?
Yeah, I will still, this one I'm saying we will still interpret in terms of odd. Actually, interpreting in terms of odd ratio is the recommended one. But sometimes also we want to predict probability of the dependent variable, in this case, women participating in labor force. We want to predict the probability that if I know the number of children a woman has below, number of children below 5 years a woman has, and I know the number of children between 6 and 18, and I know her age, and I know this thing, whether she has a college degree, whether the husband has, and I know her income, I may want to predict the probability that the woman will participate in labor force. We are still going to do that anyway. So that is sometimes people talk about they use likelihood synonymous in a synonymous manner with probability. Fine, but it's better you use the probability. Probability is also about the likelihood of participation. But
Okay, sir. Thank you, sir.
the most attractive one is the odd ratio, which we will talk about.
Okay, sir. Thank you, sir.
So, yes. Now,
Prof,
yes.
when I ran this particular model, not
Yes.
using the command,
Yes.
I noticed that there were some, okay, it's no, you have removed it from the sharing. I noticed that some preliminary summary on the top of that model table were not there.
This one.
Yeah, these ones.
This one.
Iteration, yes. No, the ones log likelihood is equal to minus 514 point, all of that. These ones were not there.
They are not in your own.
Yes.
Yeah,
When
maybe you use
command.
just which command did you use?
Is the command, sir? He used logistic in full. If he had used logit, the iterations will come out.
Okay.
Yes. If you use logit, all the iterations will come out. You copied.
I didn't
That
get
is, it copied the command from the window, from the logistic window. So when you copy it, the command is written in full logistic. Now I'm saying if he gives the command logistic followed by all the whole dependent and independent variables.
Okay. I understand what is. I understand what happens now. No.
Okay.
Sorry, I understand what happens.
Yes,
now.
go to logistic.
So, go to logistic.
No.
I'm sure the one you click was it the logistic regression reporting?
What I clicked was I went to binary outcomes and I clicked logistic regression.
The first one, right?
Yes, the first one.
And that's what
I noticed that.
Now.
No, sir. I noticed that on my own Stata version, I don't have it like your own. My own is Stata 17. So I have just logistic regression.
Okay.
Yes. Just
So
logistic.
in Stata, let me explain something now. Though we will still do that, just wait. You will see the differences,
Okay.
So that I don't jump. If you look at the what do you call it? If you look at the do file, look at line. Look at my line. Is it 31?
Okay.
Can you see the command there, logistic, right?
Yes, sir.
We are still coming to that place. You will also see after logistic, I use another one, logit, right?
Yes.
They give out two different results, and I will explain them when we get there. Is that okay?
Okay, sir.
Yes.
All right.
So for now, we are using logit, and the result we will get, so if instead of you using the menu command, use the commands in the do file. Is that okay?
That's okay, sir. So
I'm also going to use another option, no log. What happened in your own case, I can also make it to happen without, even with a logit. So if I run this one now, what you did not see, I will also not see it now. You will see that the log has been removed in this case because of this no log option that I've included. Is that okay?
That's all right, sir.
But other things remain. So if you think those ones will just be constituting nonsense, you don't really need them as such. So you might want to suppress those kind of results. So let's go back and then here yeah, it's going to still give me the same thing. So what I want to do now is to go to line 7. I want to keep all the results. So I use estimate store. I use estimate store command. So I will keep all the results in memory. Just do whatever I ask you to do so that you will appreciate the result that will come out. So this command is used in Stata. Anytime you run a model and you still want to use the result of that model later, so you can store all the results somewhere. You can give a name to the to where you want to store it. So I'm giving a name logit. You know, I could also call it I could also call it what's today? Today is Wednesday. So I could just call it this. So I run estimate. I will say Wednesday 1. So I can run this, which means the result of the logit or logistic regression that I ran previously, all the estimates, store them in this Wednesday 1. So I can run that. So it has done that. You won't see it, but it's in the starter memory. Then I continue. This time I want to run the probit for the same set of variables. So I run, and then again, even before we go further, you can quickly look at the results of the compare the result. But actually, to make the comparison easy, that's what we are trying to achieve. So let's finish this. And I say store the result from that probit. I can say keep it as Wednesday 2. Just remember that Wednesday 2 is the result from the probit. So let me store this and call it Wednesday 2. So again, that has been stored as Wednesday 2. In fact, you will see them here. These are the, this is estimate Wednesday 1, estimate Wednesday 2. Now, I now want to bring out the two of them. So I can say estimate table. So, but since I've changed, let me change the name again. Call this one Wednesday 1. Let me call this one Wednesday 2. So I can just do that. So I can say bring out the coefficients, the t, and then the use the variable width to be 30. So if I run this, you will be able to see the result now in a better format. So in this format now, you remember this will be the results from the logistic. This would from the logistic regression. This will be from the probit regression. So it's easy for me to compare the coefficient of K5 for probit, sorry, for logistic, and then for probit. This is the coefficient of K618 for logistic and for probit, and so on like that. So, of course, we see some little differences, and in some cases, you might notice that the the difference is not much. In fact, if you look at the signs, they are the same. So the signs are the same. But let me do something else to make it more clearer.
Prof, can you run this also in the model window?
Eh?
Can it also be run in the model window for us to see?
Model window.
Yes, sir.
What
Using the menu instead of the command, sir.
Instead of the command. Sorry.
No, the estimate table, I'm not sure is in the menu. It's not in the menu. Or I've not used it in the menu. So it's just, it helps you to compare coefficients, and if possible, put it in a format that you can, that is ready for publication. So you don't need to be typing. So you can just copy this straight, and it allows you.
Well, sir.
Yes.
Sir.
Yes.
Sir. Please, can we do this for linear regression as well? The simple linear regression. If you have two
yes,
different results, can we do this thing for?
Yes, now you can do that for any type of model in Stata.
Okay, thank you, sir.
Try to do that. I'm even going to use another, I'm going to jump to line 13 now. So I'm going to use word 1 here, and I'm going to use word 12 here. You will see I'm going to have more detail because it will include the t, the p-value, the variable label, and then made the variable weight to be 30. It's going to be more detailed here. So this is it. You can see the variable labels has been provided as well. It looks a bit more neater, much more better now, isn't it? So the variable labels have been provided because of this option that I included, var label. So I'm able to compare now the estimate from the logit with that of the probit. So I can see this is the coefficient. That's what this one is standing for. So it's only going to use 9 characters with 3 decimal, to 3 decimal places. So the next one is the t. The next one is the p value, and then I put the variable label option. That's why the variable, because it was not there before, that's why the variable label was not there, just the variable names were there. So this is more detailed, and easily now you could copy this into your article and discuss. Any question?
Yes, I have a
So
question.
I have a question, sir.
Continue. This is, we need to, yes, go on, ask your question.
Sir, concerning this code, sir, the command, sir, you know,
Yes.
after the coefficient, the B, you put something there, the percent 9.3F, and you close the bracket. So I want to ask, if it's for the simple linear regression, is that how we are going to write this as well?
Yes, now. You can choose.
Okay.
I explained that, what that thing is saying, and I explained here. Let's go back. This percent 9 is defining how the values should be reported. The format it should be reported. That the values, you know, a Stata has its level of precision. No, this value could be more than, in fact, up to 16 digits. So, but if you here is constraining everything that will be here not to be more than 9, and then to allow for 3 decimal places. That's why all of them are the coefficients are all into 3 decimal places. Is that okay? Is that
Okay,
okay?
Prof, my own question.
Yes, sir. Thank you, sir.
Okay, Prof, I noticed that the dependent variable was
Yes.
measured as 0, 1, and automatically it took the 0 as the reference category, right?
Yes. So
does
what,
it mean, okay,
yes, go on.
if I had coded 1, 2, does it mean it would take 1 automatically as the reference category?
No, what I show you the model we are running. The model, and you must understand this thing, otherwise we are running this model. So in the data, labor force, if the woman participates in labor force, then it's giving 1, isn't it?
Okay.
Our interest is to calculate the probability that the woman participates in labor force.
All right. So if we want the other way, we would have put LFP equal to 0, right?
If you now want, we will still talk about that actually, but that's when we want to talk about the Hod ratio, and we have not come to that.
All
now,
right.
If you now want to calculate the probability that a woman does not participate in labor force, it then means you will use 1 if the woman does not participate in labor force. But I think the one that makes sense, that will appeal to anybody, is finding the probability that a woman will participate in labor force, isn't it?
Okay, so for example, if you're doing a study that has to do with male, female, it therefore means it's the probability you're looking for, you give 1, 2, right?
Nobody calculates the probability that is going to be a male or female.
Or female.
I mean,
so I'm just giving an example of something that is not like this.
But
I'm just thinking of an example.
that is okay if you understand what to mean. But since this thing is being recorded, I have to be careful what I approve.
Okay.
Right.
So, but Prof, as an aside, since we are not touching the other models, so how do you choose a reference category? For example, maybe we have like 3. Since you said we are not touching,
I think we have this. We have. I've told you that in this discussion, our emphasis is on the dependent variable, not on the independent variable. We could have a situation here where we have a variable like marital status, which has 3 levels, but we have to create dummy variables for each of those levels. But that's not what we are doing at present. We are only considering dependent variable with just 2 categories.
Why I'm asking, Prof, you said you will not touch on the multinomial stuff. That's what I'm asking. Is there any way you can make a variable?
I can't jump this one now when we have not even finished it and start talking about
okay, it's because you said you won't touch that.
Why not master this one first?
All right, that's fine, sir.
Sorry, Prof, I have a question.
Yes, your question.
Yes. On the command, I haven't really understood what you meant by var width in brackets starting.
I think I explained. What is there is that, okay, can you do something? Go back, use that command, and make it so that you really know what is happening. Go back, put it at 10. Is that okay? And run it. You can always see how things will change. What has happened?
it has restricted the number of characters in the variable names.
You have first is talking about variable width. Variable width. The variable width. So the variable width will now be compressed because you have reduced the number of characters that you form the width. Is that okay now? So let me change it to 30 or even 35. This thing you can easily is it not better this way? Am I still there?
It is better, Prof. That way we know what we are talking about.
So some of these things just try so that you can see.
Prof, I think some of these things we can try it ourselves so that we can
excellent. So now we can predict the probability, and the command for predicting the probability is what you see there. So to predict the probability, you simply click predict, and then it will this PR logit, that will be the name you are giving to it. But mind you, yes, so that's the name you are giving to it. So let's run it. Let's run it. So the probability is already predicted, and you see it here. Let's also maybe for you to see. Let me. So what can you say about this now? So the first woman, this is the probability. This is the probability that the woman will participate in labor force. This is the probability that the woman will not participate in labor force. Even though the actual thing is that the woman participated in, did not participate. So this is the probability that the third person will participate in labor force. This is the probability that the fourth woman will participate in labor force. This probability is very low. This is fairly high, and so on like that. So you have computed the probabilities of them, and if you go to the data, you will see. If you look at the data now, you will see yourself. So this is the probability that the first woman will participate in labor force, and so on like that. So how do you get this probability? You simply use the predict command, and then you give the name to the variable. You can even summarize that variable. If you summarize, that gives you this. So the summary shows that the mean probability is 0.5705144. This is the standard deviation. Then the minimum probability is 0.005. The maximum is 0.9744. So that is quite informative. Then let's go back to our do file. You can even plot the probability. That's what line 16 will help you to do. You can plot the probabilities. So let's run this. So this is the probabilities. You know, this dot represent each woman, and there are 700 and how many women? Yeah, 753 actually. So this represents the probability. I mean, each dot represents each woman, and then you see the probability that a woman, each woman will participate in labor force. What is obvious here is that the the I mean, this is very close. The values here, so the highest probability it can take is 1. This is 0.8. This is 0.6. This is 0.4, 0.2. This is 0. There are those that are even close to 0. But it's very clear that almost 2/3 of the women have probability between 0.4 and 0.8 that they will participate in labor force. So this kind of picture or diagram can be used to explain the likelihood, or as somebody said, or the chance that a woman will participate in labor force. Then let's go back. Let's also do the same thing for the probit. So I use the line 19. So I will obtain the probabilities for the probit. I can also summarize the probabilities using the command in line 20. So this is the summary. If you look carefully, they appear to be the same. This is the one from logit. Look at the maximum there. Look at the maximum here. Look at the minimum here. Look at the minimum here. Look at the standard deviation. Look, in the logit, look at it. They seem to be the same. But let's continue to see whether they are actually the same. So if we combine, let's summarize the logit and the probit probabilities. This is the summary of both the logit, the probability of logit, the probability of the probit. You see that the mean for the two are the same, standard deviation the same, minimum, and so the point I'm trying to make here is that there is absolutely little reason to prefer either the logit or the probit. So it's a matter of choice. If your interest is to predict probability, please be mindful of that statement. If your concern is to predict the probabilities, then it doesn't, you are not gaining anything by closing your eyes and choose anyone. But most often, the interest is to be able to interpret, conduct inference. So, but before we do that, let's do a few things. So if you go to my PowerPoint, we want to compute predicted probability of woman of labor force participation for women in these 3 types of family. So first of all, we want to compute for a family with a young, a family that is young, low income, and low education with young children. What is the probability that such a family will participate in labor force? So if that is the case, then we are saying the age, if it's young, we are saying the age should be around 35. So we are saying that the number of children is with young children, so below 5 years, children below 5 years, maybe 2. And then the low education, which means wife does not have college, husband does not have college, and then low income is below 15. So we can compute the probability. How do we compute that? This is the command that we use. So this is the command here. Okay. I will still come back to, so this is the command for the first category of women. You remember there are other variables that we have not talked about. So we can use the rest function or the rest option main to say, okay, evaluate those other variables at their main level. So we simply use rest main. So we can run this. So we will get that as run. So this now gives you the probability that the woman will participate in labor force to be 0.13 if the woman is young, if the family is young and they have low income, and then the education is very low, and they have young children. So the probability is very, very small. And this is the 95% confidence interval for the probability to participate. And given this probability, you see that the chance that they will not participate in labor force is quite very high. The probability is quite high. So that's how to compute. That's how to compute that probability. And you see 2 for K5. This is the average because it's not mentioned. This is the average for number of children between 6 and 18. This is the L wage, I think log of wives estimated wages, and this is the family income excluding the wives. So this is how to compute the probability. I was trying to look at this one. You could easily plot the graph of the
Sir, the last command is not working on my own Stata, sir.
Which one?
The last one, that PR value, the last one you just did now, is busy saying unrecognized command. The PR value.
Same here, sir.
Yes, same here too. Same here.
Oh,
Same here, sir.
okay, I
Same
know,
here
I
too.
know. Okay, I did something. Can you type? Yes, you need to install something on your. There are some commands that are there is what we call ADO file. So some independent contributors, they also write command for Stata. And thank you for bringing that to my memory. I forgot. So what you should type let's say help, type help, P R value. Okay. Did you type it? Something different might come up in your own.
Yes, sir.
What did you see?
It brought out another window.
What's in the window?
Search of official help files, FAQs,
now,
examples, and STBs.
Okay. I will not be able to see your own window, but can you type that command? Can you see help s post 13_ado? Help space s post 13_ado. Can you see it?
You have blocked it with the window menu.
Okay. Type
We can see it, Prof.
Now, is this what you have also?
Yes,
sir.
Two packages found.
Yes, sir.
Okay.
Yes, sir.
So click the first one. 2 packages found. Click the first one that is highlighted.
Okay, sir.
Okay, sir.
Click it. Thank you very much for reminding me of this. Have you done that?
Yes, sir.
Yes.
Then it will bring out, you will see, click here to install. Click here to install. Have you
Excuse me, I didn't receive that too. I received another message.
Mine is even telling me it's not found.
Receive faster alert.
Maybe you didn't type correctly. Type help SPOST13_ado.
That's exactly what I typed.
And it's not working also for my part.
It's working here, sir.
It is working for. Have you installed? Click here to install.
Yes, sir. Loading, sir.
Loading.
It's not.
Yes, sir.
I only need 1 or 2 persons to get it. Once they get it, it means it's possible to everybody.
Installation complete, sir.
Prof,
It's
fine.
complete.
Installation complete.
Clap for yourself. Go and run that command back.
Yes, sir. It's not working on our laptop here, sir.
There's nothing I can. Where are you so that I can come over? Can you run the command now? Can you run the command?
Yes, maybe it's not working on Stata 13. It's not working here.
It will work.
You need internet connection for it to work.
Who is able to run it now?
There's internet connection. Prof, it's not able to.
Mine is, all the commands are telling me is not found. That's just what it's telling me.
No, the person that installed it to let me know.
Successfully installed, sir, but still unrecognized.
But it says command packet is unrecognized.
It's still not recognized.
Yes, sir.
Command packet. Yes.
It could not be opened.
No, this is the command. The command I asked you to run now is is the command, is this command, probably P add value. Are you able to run this now?
No, sir, unrecognized command.
Unrecognized command, sir.
Oh my God.
Same here.
Hey, no,
But you are, it will be unrecognized except you are able to install.
The installation was
Except you are
successful,
able
sir.
to, the installation was successful, right?
Yes, sir.
But why is it not able to recognize? Let me maybe you should use can you try the second one?
Yes,
Sorry,
I'm trying that.
Try S post again. S post 13 dot, no, sorry, underscore ado. So try to install the second one. Are you able to click this S post?
9.
Huh?
It's still not working, sir.
Click
9
this
level.
one. Huh?
It's not working.
Oh. It's
Sir,
not working here.
sir, let's continue.
Saying receive pattern alert. Don't check video.
It's installing here on my laptop. It's installing.
It's not showing. It's not installing.
So it should install.
Successfully installed,
Now,
sir. So now working, sir.
It's now working.
Yes, sir. Perfectly working, sir.
Are you able to compute the probabilities now?
Yes, sir.
Congratulations.
Thank you, sir.
Congratulations. So you'll be the lecturer for other people. Please give
So
them.
I want to install you.
No, he's going to be your lecturer. You can always find time to come and meet on the Google Classroom and let him teach you. So
Mine also work.
Eh?
My own also worked. I could
Please,
complete.
what version of Stata is yours?
15.
Congratulations.
Mine is also working.
I'm
It's
using
working.
14.2.
It's not working, no.
Congratulations.
Mine is that.
Mine is not working.
After
No,
clicking on
please.
installation, what was the next thing? It showed me a page showing installation files.
So install the file.
Prof, let's continue.
Okay, so let's continue. Few more things to do, but let's
Can't
go.
do anything like this.
So let me take you through the few things we want to see on the. So far we have been able to compute probabilities, and then we have also you can do the rest of these ones later. But
you know when you are able to
interpretation using the odds
it's not
ratio.
probably saying it's right. So it's install, not help.
Please let's leave that one, and then you can always solve it later. Is that okay? So one reason why you may want to prefer to use the logit model is because of the ease of interpretation.
Okay, please mute yourself.
You can interpret in terms of changes in the HUD. And I need to explain this before we actually compute the HUD. So the odds of observing a positive outcome uh, uh, I mean, when we talk about odds, then we are looking at the uh, the 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 likelihood of observing a positive outcome, no, against that of a negative one, and this is what is expressed here. So this is the probability that in our case, probability that a woman participates against the probability that the woman does not participate. So the ratio of these two probabilities, is actually what we call the odds. So, but it's easier to now compute the probability that they participate, because the two probabilities we ordinarily add up to 1. So since this one, once we know this, we can always know this by taking away this one from 1. So that's how this probability of not participating becomes 1 minus probability of participating. So this fraction is what we call the odds. And the log of the odds, if we take the log of it, if I take the log of this, it's also like taking the log of this side. And this log is called the logit. This is actually where the name comes in. The log of the odds is what is called the logit. So, and the logit model is linear, and this is the linear form. So, but unlike before, we were just computing the probability of participation. Here now, this linear is talking about the logit of the log of the odds. And then so if I run this regression, I will be getting my right hand side or left hand side, rather, will actually be the logit, which is the log of the odds. So we can, just to be able to help us interpret this thing, let's focus on the age side of it. So look at the age variable here. We want to focus more on this age. So the odd for age is given as this. If I take, sorry. So if I take the exponent of this side, if I take the exponent of this side, then I will simply have the odd here, the odd ratio rather. So if I take the exponent of this side, then the log will go away, and each of these will have that exponent. So that's what is happening. But I just put age here because I'm interested in age. So if I do the same thing by simply looking at what happens if age changes by 1, then I will have this. So age here will also increase by 1. And then the ratio of the two, which is the odd ratio, which is the one that is of interest to us, will give us this. So everything will cancel out, and then you will see that what we actually call the odds ratio is the exponent of the coefficient. So what the interpretation here is what happens to h when h changes just by 1 unit. When h changes by 1 unit. So is the exponent of the coefficient. And therefore, one way to quickly interpret the coefficient is to find the odds ratio. So, so interpreting the odds ratio is done this way by simply taking the exponent of the beta coefficient. And if that exponent is greater than 1, we normally say that the odds are that value times larger. And if it's less than 1, we always say that the odds are that value times smaller. So the odds ratio, they are multiplicative, they have multiplicative property in a way. So how do we demonstrate all this? Let's go back to our starter window. So, and then look at our I want to show you two things. One, let's run our logistic command again. So if I run it, this is what we used to have. This is so I run the logistic. The one we were running before was logit. Am I correct? Yes. So it is this one now that reports odds ratio. If you look at the one that is obtained when you use the logit command, you won't see ratio there, you will see coefficient. Look at this. You see odd ratio in the logistic command. Here you will see coefficient in the logit command. So, but this is the one you will interpret. This is the one with the odds ratio. And so it is this one you will now use the expression that I put here to interpret. So for a situation where the odd ratio is the odd ratio is the sorry. The odd ratio is the exponent of the beta. You can quickly compute it. Take for instance K5 here. The coefficient is minus this. So if I type display exponent of, let me put this value here, minus 1.46. The value is 0.23156075. You will see that is the odd ratio that is reported here, 0.231560. You could check this other one too. So taking the exponent of the coefficient automatically gives you the Hot ratio. Is it clear, everybody?
Yes, Prof.
It's very clear. So
Very clear.
just to explain again, if I take the exponent of the coefficient of K16 again, so again you will see this. So this is 0.9374. So this again, you will see this is 0.9. So if you run your logistic, if you run the logit command and you get coefficient, for you to interpret in terms of odd ratios, you need to take the exponent of the coefficient. Otherwise, you will now need to use the logistic command. If you use the logistic command, then it will give you the odds ratio straight away for each predictor. Is that okay, everybody? So you will now interpret that odd ratio. If it's greater than 1, it means that, for instance, in this case, this is less than 1. So you can interpret that to mean that K5, which is less than 1, you can say that the odds of a woman, participating in labor force is what value do you have there? Is 0.23, much times smaller, because the value is less than 1. So so the value is the odd is smaller, for a woman with children of below the age of 5. Below the age of 5, the odd is 0.23 times smaller for the woman to participate in labor force. So that's how you do that. Again, if you look at this is well stated here. So this is the odd ratio that is reported. So it simply says that for each additional young child, the odds of being employed or participating in labor force is reduced by a factor of 0.23, holding all other variables constant. Holding all other variables constant. The same thing, any additional
assignment wo that to mo wo target awo
mature child in the family.
David, mute yourself.
Any additional child in the family who is who is between 6 and 18 years, the odd also the odd of the woman participating in labor force decrease by a factor of 0.94, thereabout, holding other constant. But it increased, the odd increases No, because this is greater than 1. Again, this is greater than 1. So the odd increases for women that are that are that 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 have what do you call it, college degree. Yes, though. So the same thing, the odd increase, the odd of participating in labor force increase for family in which the husband, for woman in the family in which the husband has a college degree. So once the odd ratio is less than 1, then the odd decreases. The chance, of the odd decreasing. So the odd ratio is decreased. But if it is more than 1, then it increases. So you need to be able to master the way you will be able to interpret.
Prof, sir.
Yes.
For the ones that are increasing,
yes.
What's the idea of the figure now? Because we have 1 point something. Is it that the
the ones that are
increasing?
Yeah, it will now be it will be 1.2.
Okay.
Is that okay? So it will be 1.2. This one now will be 0.1. Is that okay?
Okay.
Excellent. So I think this is a good place to conclude this lecture. Except there are very burning questions.
Thank you very much, Prof. We really appreciate the patience and the painstaking approach to attend to questions that were coming in the process, as well as making sure that we are able to complete what we're supposed to complete today. Now, I want to just like Prof has said, if there are burning questions, can we quickly entertain that before we round off, given that we had exceeded our time limit, as it were? I don't know whether Akim
I have one. Hello, Prof. Can you hear me?
Go ahead.
Yes, I can hear you.
Okay,
please.
Prof. When we're trying to predict probabilities, it
Yes.
was showing not in labor force, but the actual probabilities, you were interpreting it as in labor force. I want to be sure about that.
Sorry, take it again. When we were predicting,
when we're trying to predict probability, both for logit and probit,
yes,
when the table came out, it was showing not in labor force, but you were interpreting the probabilities as in labor force.
No, I interpreted the two.
That means I didn't
So
get
because it reported the probability for being in labor force and for not being in labor force. Do I show you again?
I will go through the video again. No problem, Prof.
The two, when we computed, the two were, let me just quickly show you, just to be allay your fears. Yeah. So can you see the probability? The first one is the probability that the woman is in labor force. Can you see it? The
yes,
probability is 0.1327, and this is the confidence, the 95% confidence interval. Then the second one is the probability that the woman is not in labor force. No, condition on the predictor variables. This is it. Ordinarily, the two of them to add up to 1. Is that
One.
okay? Is that
Yes,
okay?
but this is actually not the table, but it's fine, Prof. I'll go through the video in order not to waste time.
Thank you.
Thank
very
you,
much.
Epsiba. Thank you for that. So that we can have our time saved. Okay, any other question? I see that Abdulhakim is raising hand. I wouldn't know whether that's a mistake or it is to ask a question at this point.
It's a mistake, sir.
Okay, you can lower it, please. So any other question? Okay, Prof, we can take it that there is no more question at this point. So on that,
Just a suggestion.
Can you come again?
Suggestion.
Okay, let's have.
For the sake of quiz now, since some of us are having an issue running that command PR value, I think Prof should help out because we can't run that command. Don't know what's happening.
Question will come from there.
What version of Stata are you using?
I'm using version 20, Prof.
There is no yet version 20. Was it made specially for you?
Only for chief people in Benue State, Prof.
Oh, Stata for special people, right?
The recording can stop. Let's stop the recording. If not, the megabyte will be excessive.
Okay, it's all right. We'll stop the recording now.